All right. Hello, everybody. Let's give a warm welcome for Graham Dumpleton here. He's the author of ModWSGI, and he's going to talk to us about making Apache suck less for hosting Python.
If you want to follow along with the slides for this talk, you can find them on SlideShare. The slides do have presenter notes, so you can also read it all again later if you're too busy surfing the net at the moment, or if you didn't catch some point. So these days there seems to be a never-ending line of people who will tell you that Apache sucks and that you're crazy if you use it, especially for hosting Python web applications. What is the truth? Do people who make such claims actually understand how Apache works, or are they just repeating what someone else tells them? As the author of WSGI module for Apache, what I want to do in this talk is go through and look at what some of the pain points are when configuring Apache to run Python web applications. The intent is that you can walk away with a bit more insight into how Apache works and what is required to properly set up Apache and mod WSGI. So if you like, I'm going to explain how to make Apache suck less. So the biggest criticism which seems to be leveled at Apache is that it's bloated and uses too much memory. There are various reasons Apache can use a lot of memory. Many of these are under the control of the user and not necessarily a failing of Apache though. Another criticism is why is Apache so slow? Like with memory usage, this can also have a lot to do with how Apache has been configured. In practice, if Apache is simply set up properly for the specifics of running dynamic Python web applications and taking into consideration the constraints of the system it is also being run on, neither of these should really be an issue. The first thing one can do is strip down what Apache modules Apache is loading. Because Apache is a workhorse that can be used for many different tasks, it comes with a range of pluggable modules. There is likely going to be any number of modules getting loaded that you aren't using. To cut down on base memory used by Apache itself, you should disable all Apache modules you are not using. Beyond the server, it has to be recognized that any use of Python will cause an immediate increase in memory used. You load a typical web application along with all the modules from the standard library it requires, as well as third-party modules, and memory use will grow quite quickly. The actual base memory consumed by the web server at that point can be quite small in comparison. Overall, it shouldn't really matter what WSGI server you use. The Python interpreter and the Python web application itself should always use a comparable amount of memory for a comparable configuration. The laws of nature don't suddenly change when you start using Apache, as some people would claim. Memory used by the Python web application itself in a single process should not suddenly balloon out for no reason. An appearance, therefore, of increased memory usage is more likely going to be due to differences in the server architecture. Now, when I say server architecture, I specifically mean the mix of processes versus threads that are used by the server hosting the WSGI application to handle requests. Using processes in preference to threads will obviously mean that more memory is going to be used. The big problem in this respect is that beginners know no better and will use whatever the default configuration is that their server distribution provides. For Apache, which is often supplied with a Prefork multiprocessing module or MPM, this can very easily cause problems because it uses single-threaded processes. Although Prefork MPM may only initially start out with a single process, it can automatically scale out to 150 processes. That's 150 copies of your Python web application. At 20 megabytes per process, that is already 3 gigabytes. And at 20 megabytes, that would be considered a small Python web application. In contrast, Gunicorn Sync Worker defaults to a single process and single thread and doesn't automatically scale. The memory requirements of Gunicorn would therefore stay the same over time. So Apache presents a much bigger problem. So whatever you do, don't use the default configuration that comes with your server distribution. For Python web applications, you generally can't avoid having to tune it. This is because the Apache defaults are set up for static file serving and PHP applications. Especially don't try and use the same Apache instance to host Python web applications at the same time as running PHP or Perl applications, as each has different configuration requirements. How do you work out which MPM you are using? Prior to Apache 2.4, the type of MPM being used was defined when Apache was being compiled and was statically linked into the Apache executable. From Apache 2.4, the NPM can also be dynamically loaded and so defined at runtime by the Apache configuration. Either way, you can determine the NPM in use by running the Apache executable with the -v option. Another way of determining the specific process architecture in use is by consulting the multiprocess and multithread attributes passed in the WSGI environment with each request. Neither of these, though, will actually tell you how many processes or threads are in use. For that, you need to start looking at the Apache configuration itself. This is where we can actually end up in a trap. For the standard Apache configuration with the Apache Software Foundation's own distribution, although there are example NPM settings provided, that configuration file isn't actually included by default. The settings in that file are also different to what is compiled into Apache. So you can't even use it as a guide to what the compiled in defaults are. So although I said before that the Prefork NPM could scale up to 150 processes automatically, that was on the assumption that those default settings in the Apache configuration file were actually being used. If those settings aren't used, then it's actually instead 256 processes, making it even worse. Some people recommend throwing away the default configuration files and starting from scratch, meaning that one uses the more lethal compiled-in settings. For those who are not familiar with these settings, what do they actually mean? Start service is the initial number of processes created to handle requests. Because Prefork uses single-threaded processes, the maximum number of processes ends up being dictated by the value of max clients. The settings which need more explanation are the min and max spare processes. The purpose of these is to control how Apache dynamically adjusts the number of processes being used to handle requests. In very simple terms, what Apache does is wake up each second and looks at how many idle processes it has at that point which are not handling requests. If it has more idle processes than the maximum specified, it will kill off a single process. If it has less idle processes than the maximum spare required, it will spawn more. How many it spawns will depend on whether it had spawned any in the previous check and whether it is creating them quickly enough. When presented with the NPM settings being used, even I have to think hard sometimes about what the result of those settings will be. To make it easier to understand, I run the settings through a simulator and chart the results. In this example, the number of concurrent requests is ramped up from 0, and when maximum capacity is reached, it is ramped back down to 0 again. By using a simulator and visualizing the results, it becomes much easier to understand how Apache will behave. We can see when Apache will create processes or kill them off, what the total number of processes will be as it scales, and how that is being driven by trying to always maintain a pool of idle processes within the bounds specified. Zooming in on the chart for the total number of processes available to handle requests, one thing that stands out, for example, is there is an effective floor on the number of processes which will be kept around. No processes will be killed if we are at or below this level. Too often people who have no idea how to configure Apache get in and start mucking around with these values, not understanding the implications of what they're doing. The simulator is great in being able to give a quick visual indicator as to whether something is amiss. One example is where the number of servers to be started is less than the minimum number of spare servers. What happens in this case is that as soon as Apache starts doing its checks, it sees that it isn't actually running enough processes. It therefore starts creating more, doubling the number each time until it has started enough. Rather than actually starting all processes immediately, in this case it takes 3 seconds, thus potentially limiting the initial capacity of the server. At the other end of the scale, we have people who change the number of servers to be started to be greater than the maximum spare allowed. This time when Apache starts doing its checks, it finds it has more idle processes than allowed and starts killing them off at a rate of 1 per second. Presuming no traffic came in that necessitated those processes actually existing, it would take over a minute to kill off all of those excess processes. To avoid such delayed process creation or immediate killing off of processes on startup, you should ensure that the value of start servers is bounded by the min spare servers and max spare servers. Why do we care about unnecessary process creation? After all, aren't the processes just a fork of the Apache parent process and so cheap to create? The problem is that unlike mod PHP, where PHP is initialized and all extension modules preloaded into the Apache parent process, when using mod WSGI, Python initialization is deferred until after the processes are forked. Any application code and required Python modules are then lazily loaded. If initializing Python and loading the WSGI application in the worker process can be expensive, why can't we preload everything in the Apache parent process before the worker processes are forked? Even if a Python web application were designed to be able to be preloaded and run properly after the process was forked, the key issue is that users' application code on startup would run as root if executed in the parent process, and this is one very big security risk. Add to that, because of what Python does, or should I say doesn't do, when the interpreter is destroyed, combined with the way in which Apache reloads mod WSGI when restarting, the Python interpreter will leak memory into the Apache parent process. If Apache restarts are done on a regular basis, the size of the Apache parent process will grow over time, and thus so will the forked worker processes. Effectively, you have a memory leak. So running within Apache, we have no choice and have to defer initialization of Python and loading of the WSGI application until after the child processes are forked. This causes additional CPU load each time a process is started up, and the time taken will also mean that requests will be held up. Finally, because we are not preloading in the parent, we cannot benefit from reduced memory usage from copy on write features of the operating system. Process startup is therefore expensive. We want to avoid doing it, and certainly don't want it occurring at a time which is inconvenient. Unfortunately, especially with Prefork MPM, allowing Apache to dynamically create processes can result in a lot of process churn if you're not careful. The more problematic situation is where there is a sudden burst of traffic and there is not enough processes already running to handle it. In the worst case scenario, the increased load from creating processes when a sustained traffic spike occurs could see the whole system slow down. The slowdown can make Apache think it isn't creating enough processes quickly enough, so it keeps creating more and more. Pretty quickly it has created the maximum number of processes with the combined CPU load of loading the WSGI application for all of them causing the server to grind to a halt. Even after the processes have been created, we can still see process churn. This is because Apache doesn't look at request load over time. It only looks at the number of concurrent requests running at the time of the check. This can actually bounce around quite a lot each second. There will therefore be a continual churn of processes as Apache thinks there is more than required and kills them off, and then when it again believes it does not have enough and creates more. What if we raise that floor on the number of processes as determined by the max spare server setting? We said that so long as the number of processes was below this level, none would be killed off. Let's try then setting that to a level above the average number of processes in use. What will happen is that although there will be an initial spike in the number of processes created, after that there will only be a slow increase as the number of processes finds its natural level and plateaus. So long as we stay below max spare servers, we will avoid process churn. We haven't set the maximum number of spare processes to the maximum allowed clients quite yet though. So it's still possible that when a spike occurs, we will create more than the maximum spare allowed. When traffic recedes, the number of processes will reduce back to the level of the maximum and no further. Finding the optimal level for the maximum spare processes to avoid churn can be tricky, but one can work it out by monitoring utilization. Do be aware though that all this work in tuning the settings can be undone by the max requests per child setting. We want to avoid process churn. It is no good setting this to such a low value that this would cause process recycling after a very short period of time, as it just reintroduces process churn in another way. It is better to have this set to 0, resulting in processes staying persistent in memory until shutdown. Now, the only reason that the defaults for Apache specify such a large value for max clients, and thus a large number of processes when single threading is used, is because of slow clients and KeepAlive. A high number is required to support concurrent sessions from many users. If using single-threaded processes, though, this means you will need to have much more memory available. A much better solution is to put an Nginx proxy in front of Apache. The Nginx server will isolate Apache from slow clients, as it will only forward a request when it is completely available and can be handled immediately. The Nginx server can also handle KeepAlive connections, meaning it can be turned off in Apache. This allows us to significantly reduce the number of processes needed for Apache to handle the same amount of traffic as before. Key in eliminating unwanted CPU usage was therefore avoiding process churn, which is achieved by adjusting the maximum allowed number of spare processes and ensuring we aren't periodically recycling processes for no good reason. We can, though, also reduce the number of processes we need in the first place by adding Nginx as a proxy in front of Apache. All of what I've explained so far focused on Prefork MPM. I've concentrated on it because it magnifies the problems that can arise. When people say Apache sucks, it is usually because they were using Prefork MPM with an inadequate configuration. Use of Prefork MPM with an Nginx proxy will give you the best performance possible if set up correctly. But as I said before though, using worker MPM is much more forgiving of you having a poor setup. The reasons for this are that for the same large default of max clients, worker MPM will use a lot less processes than Prefork MPM. This is because each process will have 25 threads handling requests instead of one. Being less processes, worker MPM will therefore see less copies of your Python web application and so less memory usage. In the case of worker MPM, by default, 3 processes would be started initially, with the compiled in defaults. With max clients of 400 and threads per child being 25, that's a maximum of 16 processes which would be created, instead of 150 or 256 in the case of Prefork. Settings related to scaling when using worker MPM to refer to threads, whereas with Prefork MPM they were in terms of processes. Max spare threads defaults to 250, which equates to the equivalent of 10 processes. One very important thing to note is that although these are expressed in terms of threads, Apache doesn't scale at the thread level. The number of threads per process is static. When scaling, it is the same as Prefork. A process will either be created or killed. The decision, though, is based on available threads instead. Running our simulation of random traffic from before with a similar level of concurrent requests, and although we still had an initial spike in creating processes, no new processes were needed after that, as we were within the level specified by max spare threads. No churn means no wasted CPU for continual creating and killing processes. Using the compiled defaults at least, this is why worker MPM is more forgiving than Prefork MPM. As before, and especially if using Nginx as a front-end proxy, one can adjust max clients, min and max spare threads, and perhaps bring down even further the amount of resources used. A more important setting, though, is max mem free. This is the maximum amount of memory the Apache per thread memory pool is allowed to hold before calling free on memory. Prior to Apache 2.4, this was unbounded. In Apache 2.4, it is 2 megabytes. Even at 2 megabytes in Apache 2.4, this could mean that for 25 threads, 50 megabytes can be held by the persistent memory pools in each process. When running mod WSGI under normal circumstances, there should not be much call for memory to be allocated from the per request memory pool. To be safe though, you should ensure max mem free is set and with a reduced value if possible. Now the configuration for Prefork or worker MPM are principally an issue when using what is called embedded mode of mod WSGI. That is, your WSGI application runs inside of the Apache server child processes. The dynamic scaling algorithm Apache being what can cause us grief when doing this. Using worker MPM helps, but an even safer alternative is to use mod WSGI's daemon mode instead. In this case, your WSGI application runs in a separate set of managed processes. The main difference when using daemon mode is that there is no automatic scaling on the number of processes. The number of processes and threads is instead fixed. Being fixed, everything is more predictable and you only need to ensure you have sufficient capacity. Using daemon mode, the need to have Nginx as a front end is reduced, as the Apache server child worker processes are serving much the same purpose in isolating the WSGI application from SO clients. Because the Apache server process is now only acting as a proxy, forwarding requests to the mod WSGI daemon processes, as well as serving static files, we don't need to initialize the Python interpreter in the Apache server processes. Process creation is again lightweight, and we have sidestepped the need to pay so much attention to the Apache MPM settings. So Apache can certainly be a challenging environment for running Python web applications. The main pain points are how its algorithm for dynamic scaling works and memory requirements to support high concurrency. With careful attention, it is possible, though, to configure Apache to reduce the problems these can cause. The simulator I demonstrated can be used to try and validate any configuration before you use it, but the random nature of website traffic means that it will not be conclusive. This is where live monitoring of traffic in your production website provides a much better level of feedback. New Relic is obviously the package I would like to see you using, but any monitoring is better than none. In New Relic, one of the reports it generates, which is particularly relevant to coming up with the best processes threads configuration, is its capacity analysis report. From this report, one can see whether you have provided enough capacity or whether you have over-allocated and so wasting memory, or running your application over more hosts than you need, and therefore paying more money for hosting than you need. Although this talk has been about Apache and WSGI, this report is just as relevant to other WSGI hosting mechanisms, such as Unicorn and WSGI. Working at New Relic and being able to see data coming in from a wide variety of deployments, it's really quite amazing how poorly some servers are being set up out there. And not just when Apache is being used. So if you are using New Relic, I would really suggest paying a bit more attention to this report. Doing so can help you make your server run better and possibly save you some money as well. And that is all I want to cover today. If you are after more information, especially if you're interested in the simulator I demonstrated, keep an eye out on my blog for more details of that sometime in the near future. If you can't wait, it is up on my GitHub repo. I do have to go back and clean it up and add a bit more Docker, but you might be able to work it out. If you're interested in using New Relic to better configure your WSGI server, then you can catch me in the expo hall after this talk.
Thanks, Graham. We'll be taking questions at the microphone in the center here, so if you have a question, just stand up and walk over to the mic. And while we're waiting for people to walk over there, just a quick announcement again about we're having a Pie Ladies auction tonight at 6:30 upstairs in rooms 209 and 210. Everybody go bid on stuff. There's going to be a bunch of cool stuff there. I think some iPods, iPhones. There's some stuff signed by Guido. All kinds of stuff. Thanks.
So I'm curious, during what phases of the request is the WSGI daemon process actually active and occupied by a request? So you mentioned that Nginx will buffer the request until it's fully available if you're using embedded mode. Does Apache serve that process if you're using daemon mode? Or are there other concerns around there that we should know about?
So what Nginx will do is that it will read in all of the request headers and by default buffer up to 1 megabyte of request content before it decides to start streaming it through to the back end. When you talk about in daemon mode of Apache, of WSGI, Apache will read all those request headers, but it will start streaming immediately through to daemon mode. So it's a little bit different. So it's not providing as much protection. And combine that with the fact that Apache is still using threads or processes for the main server processes, which are doing that proxy. You still have to set your number of max clients quite high. So Nginx still provides a better isolation from those slow clients in that sort of situation. But if you don't have a really, really high demand site, then you could get away with just daemon mode and not require Nginx in front.
So do you need the number of daemon processes times the number of threads they each run to be about the same as what it would be if you're using embedded mode?
If you're going to use Apache for also serving up static files, then it's handy to still have an extra capacity within the main server worker processes. So it doesn't necessarily have to be a one-to-one correspondence. And in some respects, if you have it be a one-to-one correspondence, then you can't queue up requests in the main Apache server processes. They'll still queue up, but on the listener socket, not in Apache itself. But it gets all very complicated. I talked about this issue of backlog in my talk here at PyCon last year. There's a whole can of worms in there, and it wasn't something I had time to cover in this talk. I can see it very much being the topic of my next talk, which is that whole issue of configuring daemon mode especially, and the whole issue of backlog and all those sorts of things. So I don't have a simple, quick answer here now, but keep an eye on my next talk, because that's, I think, what I'm going to do it on.
Thanks.
Hi, I'm not sure if this is a quick answer either, but maybe if there's a guideline or rule of thumb for how many processes and threads would be good in a configuration. I would assume for processes that you'd want as many as could fit into memory, but I'm not real clear when configuring how many threads you'd want to set up.
Okay. Putting too many threads doesn't work that well. I've seen people who will put 100 threads. There's a few different issues. Let's consider embedded mode first. If you have a high number of threads, Apache will delegate requests to them randomly, which means that because every time you go into one of these threads into Python, it has to initialize all the extra memory, thread state for that thread. So it'll end up using a lot of memory. You might, more than likely, will not only be using a small number of those threads. So if you have low traffic and you put the number of threads really high, you're actually killing yourself. You're going to use more memory and not utilize everything properly. If you use daemon mode, it's not so, that sort of situation is not so problematic, because in daemon mode it specifically has a last in first out strategy on thread assignment. So even if you put 100 threads, if you only end up using 5, it'll never actually initialize all the rest. So the model's a bit different. Now what I've found personally is that in daemon mode especially, if you run 5 threads per process, and you might run a few processes, that actually can handle a hell of a lot of traffic. You see people who will put huge number of processes, huge number of threads, thinking, oh yes, I need to handle 10,000 concurrent requests, but because the response is not a full second, and you don't have 10,000 concurrent requests, they're over allocating. But I found that about 5 threads per process is a nice figure.
Thanks.
All right, well, if we don't have any other questions, let's give Graham another round of applause here.